Hi friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2644. Find the maximum divisibility score. This problem is an easy problem, so our purpose in this video is to demonstrate how to analyze the process or analyze the problem and then come up with a solution. So we take this example as an example to demonstrate the thought process. So here we have two arrays, so nums and divisors. So the divisibility score of a number in divisors is the number of elements in nums that can be divided by this divisor, right? So here we are required to return the integer divisors I, in other words, an element or an divisor in this divisors list. So with the maximum divisibility score. And if there is more than one integer with the maximum score, so we're going to return the minimum of them. So here are three examples. Let's look at the last one, example 3. So here we have only one element in nums, and the divisors contain two elements, 10 and 16. Both the two elements have score 0. So in this case, we need to return 10. So this is 1 point from this example 3. And in example 1, so notice that none appears twice in this example. So we are going to deal with this situation. And in this case, we can check that the score for the 3 is also 3, right? We need to return the divisor 3 here, right? Because none, 3, none can be divided by this 3, right? So in example 2, we also notice that 5 appears twice in the divisors. But you know, the same elements in divisors for sure have the same divisibility score. So essentially only one of them play a role, right? So this is to be noticed. So basically, example 1 demonstrates us that so a number can appear multiple times in nums, and example 2 demonstrates to us that a divisor can appear multiple times. So we need to embrace or take these 2 points into consideration in our coding. So the example 3 demonstrates to us that we need to return the minimum one if there is a tie. So with that said, let's also look at the constraints. First, the nums and divisors both bounded above by 1000 in length. But if we consider the square of 1000, that would be 10 to the power 6, right? And the second item basically about the range of elements in the two lists. So with that said, we're going to analyze the problem. So here for this problem, first we notice that multi-occurrence, right? Multi-occurrences. So let's see how to treat that. So that one is in nums, right? So we are going to, because if none is divided by 3, so we may count score. So we have 2 nines, so we need to count these 2 frequencies. So we are going to make nums it counter, right? So let's use this maybe. We are going to count the unique element and their frequencies, right? So this is for the computation convenience of the divisibility score. And also there's multi-occurrences in divisors, but same divisor have the same divisibility score. So essentially we need to transform the divisors to be a set. So from list to set. So this will be our principles. And next we are going to do the coding. So well, for the coding, because this is an easy problem, we can do it in a verbose way. First, let's do the preparation step. So this preparation is based on the multi-occurrences treatment. First, I'm going to make divisors a set. So here I'm going to use type conversions. So this way we actually avoid some multiple checks, right? For example, if a same divisor appears 1000 times, so we just need to check one. So this is the one. Another one is we're going to make a counter from the nums collections counter. So this going to give some nums. Let me print one just to check it's correct. Oh yeah, we're going to get this thing right. So next, let's look at the problem logic. So for this problem, it's very easy. So I'm going to write a utility function. So basically, we want to check for one divisor its divisibility score, and then we're going to map this function to every divisor, right? So let's do this. Let me define this div score. So given an divisor y, so by assumption, so we can assume that this y is positive. Let's see, it's greater or equal than 1 because it's integer. And then, so here basically because we need to use division, right? So we want to use modulo operation. So here we have a result. So this is a temporary a local variable within this function. We're going to count the number of elements in nums that can be divided by this y. So basically we are going to iterate over the dictionary, right? So for n and its frequency in count items. What we're going to do is we're going to check if n modulo y is 0, which means that y is a divisor of n or a factor of n in the sense of multiplication. Then we're going to increment the results by this frequency, right? And then we're going to return the result. So this is our utility function, right? Next, we're going to map this function to the set divisors. So, or we can just prepare the return and use a for loop. So that's also good. So here, so you can try map. So just make a map function, right? But here, let's just due to the return format, so we just use a for loop. So score. So because it's the score is at least 0, so I'm going to have a smaller one just to use some proper initialization, right? And then we're going to iterate, right? So for divisor or for y in divisors. So what we're going to do, let's first get its divisibility score. That's div score of y, right? And then we're going to check if temp is greater than the score, right? And then we're going to set the result to be y and the score to be the current score temp, right? Otherwise, let's use an else if temp equals the score, right? So in this case, we're going to we do not update the score because they're the same. We just need to update the results. But here we want to return the mean of results and the y. So in this sense, we'd better to make a larger one for this result because the nums length is at most 1000, right? So we can actually choose 1001. Let's see. So actually, you can choose any one because we choose -1 for score. But you know, logically, it's better to choose this one because we're going to use min operation. So with that said, now we're ready to return the result. So this is one way to view this problem or treat this problem. So before we make further comments, let's do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So with that said, I guess that's about it for this problem. Basically, for this problem, which is an easy one, we need to notice how to treat the multi-occurrences phenomena in the demonstrated by the example given, right? So with that said, basically we can use a verbose way to do this problem. With that said, I guess that's about it for this video. Thank you.